G'day Bifrosters, welcome back. This is part 2 of a however many part series where I explain and hopefully rebuild this thing. So in the introduction I took you through how the rig worked and what all these things did and how they were all hooked up, which is great. There's a couple of things I found in the introduction, like don't reduce that below 3, that I need to fix. But mostly it's all working quite nicely. So this episode we're going to jump into the Bifrost, and we're not going to start any rebuilding just now. I'm just going to take you through how things work and see if I can remind myself how I made them work in the first place. Yep, basically. So let's get on to that. So when you first, I wasn't using corner S shapes. When you first open it, that's what it looks like. So obviously I spent some time organizing it, so we'll do what we should do and start at the beginning and work our way through. So this is our main input, which I had a quick look at in the intro, and it's quite obviously full of controls. Let's turn this off just to make things a little easier. We'll make sure everything's off and happy before we start doing anything. And I know that the heart of this is instancing, pretty much, which all happens like there, more or less. So you've got material stuff. I have labeled these as just the labels are tidy. Strands render material setup and create the wires, random culling. That should be normal, and random rotations, and create custom points to insert. And so this is, for example, this is the custom bit that does the custom points. So to break it down, I guess we've got to kind of take it in order from the bottom up. So what we should look at first, I think, is the instances and what's going on with them. So there are the instances being made, and here are the strands being, well, this is the strands setup. This is the strands being made here. So create the wires. Essentially what's going on is I have a incoming curve, which Bifrost treats as a strand. So that's in there. Oopsie daisy. That comes on down to here. This is where we switch our inputs, basically, which is just a get from array, more or less. So it's getting the array size. This is just making sure it doesn't. No, this is if your value is higher than the number of things in the array, it stays with the top level of the array. So that means that I can only ever get curve input 0, 1, or 2. Even if I put 64 in there, I'm going to get 2 because it's the last in the array, which is what this does. So that's just a little bit of protection there, but this is getting it from the array. And then we go into our resample strands. At the moment, this is just the wire coming through. And then we're going to resample that. And this is, oh, man, my bad. It's been a while. You're going to have to put up with me having little epiphanies every now and again. What this resample does is it resamples the master strand, so the curve coming in, and then feeds it out to wherever it needs to go. And that's to make this curve smoother. So this is what enables us to change the number of power poles that we have. Like so. Presumably too, if I drop that to 0, it's going to crash. So that's something I'll need to make a note of to fix when we go through it. So once that's all sorted out, it passes it through to the master strand pass-through. And what that does is pretty much what it says. It passes the master strand, which from now on this is the master strand. These strands are different. The ones that make up the wires are different. This one is quite simply the curve that they all go across. That's how I've been differentiating it to myself. Oops, don't do that. Do this. Yes, thank you. So that comes out and goes straight into the create the custom points and then insert into master strand points array. So this is where we're with our custom point, when they're switched on, they are inserted into the strand points here, and the strand points just live as an array. They're just points on a strand and they have an order. What this does is it'll loop through all the custom points, I think. Yep, it's getting the closest 2 points in radius from the master strand in that search radius, and that's the red. If I just jump back over here quickly and turn on custom points, you can see that these red circles turn up, and the red circles are the radius from this value here, basically, this radius here, which just comes from this node which is hanging out doing nothing because I haven't hooked it up. So this is searching within this red circle to find the two closest poles on either side, so it can then put this between them. So it finds closest to, gets the first, sets that in the array, pops the array out. So because, sorry, what I should have said there is it gets the first in this array, so this is the closest to, and then sets our new value. So this is our input translations from the custom point, which you can find if we go along this line here. Comes in from a matrix, so it's the translation of this matrix, which is all the way back here. This line is the custom points. So it's finding the custom point position here. Now there's 3 custom points, so this is a loop that loops through all of them, and it's finding whichever master strand points are closest here. If we go inside this is going to get quite involved. Master strand comes in, there's just closest accelerator, sample closest in radius, and out it goes. So that's just your normal sample closest radius node. And then I believe I've probably got that set in here somewhere. So yeah, max number of 2. Then it takes the first of that because that's the point at which I'm going to insert afterwards, and then it inserts the new point and then pops it out. And that's our new master strand, our up points array. And then it gets made into a strand there. So this replaces the old one. And that's if the custom points are enabled only. So there's the true, and the false is just the master strand as it was. So before we do anything else, we're checking to make sure that everything that needs to happen to this curve happens to it. And then this up here is just basically the point radius, so it's the red thing. This is what switches it on and switches it off when we select it. Now we've got our master strand coming out here. So let's remember that. Let's move this out of the way to make sure we're not getting all mixed up with our many lines. And this comes into update strands basis. So this is getting the point tangent, point normal, and point binormal of the master strand, and this is what allows us to do our orientation. And this was originally a strands basis to orientation node, but I've done a little bit of editing to it here, and you can see it's fairly clumsy, but it works. This is the random rotations, and then this is the random quaternion. Quaternion, got it. So this is the random coming in, and this is the normal and tangent, where it normally does all the working out based on the strand, normal and tangent. This is now multiplying those two together, so we can have random values multiplied with the normal and tangent stuff that's already there, sets it to point orientation, and spits that out. And that's this coming out, goes into the random cull, which basically just allows me to cull based on position using a weight cull here. And then I'm just taking the deleted indices and deleting them from the array. And I've got 2 arrays at this point. I've got the quaternion array and I've got the points array. And they're both just running in dual. And this becomes fairly important later on. From here, this goes out and does the instances. So this is, this sets the point orientation again. From here, just using the quotes here, see quotes, that works, to set the orientation. As well as that, now it comes to create the wires, and this is where we start to get a bit, what should we say, complicated. So we have to go right back to the beginning and take a look at what these two are. And what these two are controlling the wires coming in, and this array are my attachment points. And I spoke a little bit about this in the let's just go and show our master instance, focus on it. I spoke about this a little bit in the introduction where you can see there are 4 locators sitting on these, and this is where my strands will attach to the poles all the way down the chain. And all this is doing, all this attachment matrixy stuff is doing right now is it's getting the positions of these 4 locators. This here, the slice array, allows me to basically, if I select my Bifröst like that, this is what allows me to do the number of wires. So you can see there, I've got like no wires, 1, 2, 3, 4. That's just slicing the array of these attachment point positions using the number of wires as the stop. So anything above 4 is going to return 4, obviously. But other than that, this is just slicing that array up at that point. So that's how I can get the number of wires that I want. Then my resulting matrixy array goes all the way back out to here, and we start to do the attachment points in a loop. So we get our matrix here, we're looping through each one. Matrix to scale, rotation, transform, translate. The translation goes out, gets rotated by a quad coming in from here, which is the main strand point quads. I've named everything, it's great. Which is what we just went through before, where we were updating the basis and then adding and multiplying a little random onto it, if we so desired, which are what these are. So these control that. So we're getting the positions and the quads out for each attachment point. So I'm taking the translation, I'm rotating it by that quaternion, oh, my brain. Quantity, qualification, quail, quaternion. It's taking the translation and rotating by that quaternion and then adding it to the main strand point position. So what that is essentially doing is it's taking these, well, each one of one by one, it's in a loop, so it's one by one. It's taking this transform of this attachment point, rotating it to match whatever it's at on the curve at this point, and then adding it to the point position. And what that means is that I'm instancing from the base. So this position from here to any one of these is what is being added on here. So essentially I'm rotating these separately and then adding them to the point position, adding them to the instance position, so it doesn't look like they're rotating the wrong way. And that all works. Here's where we split into the single wires. We're using a lot of sequence arrays to do that. It's been a while since I've looked at this, so against the size of that array, takes one off it. I could have just used decrement there, that's new. Then I've got a sequence array that starts at 0 and steps by 1 to the size of this. And that goes out to another sequence array that's the size of 2 and steps by 1. Then it gets that from the original array and outputs it. Okay, I'm sure that's going to be clear as mud when I get to it. And we've got, now we have an array of arrays, and it's a size 4. So this is splitting up the 4 wires, or the 3 wires, or the 2 wires, into an array of each one. Then this is where it constructs the wires, using those points coming in along each separated array. This is just setting the shape to be a ribbon right now. I'm not sure why that's there. We'll investigate that. And this here is how we're doing our sag. So this is just a F curve set to that. It's got nothing coming into it. It's just this curve here from 0 to -1 back to 0 again. So it's the sag that I want. If we come in here and take a look at what's going, it's going through one by one wire, going through each wire, and then in here, so it's taking each strand, and that's getting out there. Then we're getting a random value, multiplying by the random value. This is if we wanted, what this if will connect to is the randomized sag. So this is where the randomized sag comes in, which is this guy. That gets back up into here. What's this? Is this a loop? No, this is just a compound to keep things interesting. So this is our sag value. If we turned on randomized sag, it comes through here. If we haven't, it's just taking the sag value straight out of here. This here. Inside faked hanging curves. So we've got our F curve now coming in, which is the curve that we set up out there. And we're multiplying that by we're applying that curve to the Strand's point ratio, then multiplying it by the sag value, then adding it back to the positions, turning it all back into a vector and spitting it out. So for each point, it's applying, it's been a while, it's applying that curve based on the Strand's ratio. So what the Strand's ratio is that at the start of each strand, the ratio is 0. The end of each strand, the ratio is 1. So it's essentially just applying that curve across the ratio based on the things we give it. And then it flattens the nested array to get the required wires out, and then it goes off to rendering. So that's thickness, render settings, the surface is here, assigns the material, here's our output. So instances out, strands out, and diagnostic I'm not sure why that's there. Diagnostic, it's badly named, and I should fix that, but that's what's giving us our custom points. Whew! It's a bit of a run through. I'm not going to break it down any further right now. Well, basically because I'm not sure I can. I'm going to have to rebuild it. Oh, I probably can, but let's face it, I've taken you through most of it, and I've got to edit it. In the next episode of this long and crazy thing, we'll start trying to actually rebuild this and see how we go. All right, so I hope that was a good part 2, and I'll see you next time. Thanks.